Good morning, everybody. Let's take a look at your Systems of Equations worksheet. So when I look at these problems again, when we talked about what happened today in class, is either we are doing the substitution method or we're doing the elimination method. You can choose which method you're most comfortable with, but I'll tell you right now, certain methods go better with certain problems. For instance, on number one, since y is all by itself in the second equation, to me, this is a key that you should use substitution. So I know that y is the same thing as x minus 1. So I'm going to plug that value in for y into the first equation. So what I do, I have 3x minus 4 times the quantity x minus 1, because I'm replacing y with it, so I replace it by putting it in parentheses, equals 8. Now, once I have done that, I have a single equation with only x's. So now it's just a matter of distributing and simplifying. When you distribute, you have to distribute that sign along with it. So we have 3x minus 4y plus 4 equals 8. Then what you can do is start to combine like terms. So 3x and minus 4x is negative x. Plus 4 equals 8. Then just solve for x. So I'm going to subtract 4. Negative x equals 4. But if it's negative, to get rid of that negative, divide by negative 1. So x equals negative 4. Alright, then most people will stop right there and say, hey, we're done, but we're actually not. You still need to figure out y. So I'm going to take that value back and plug it into actually the bottom equation, since y is all by itself. So I have y equals negative 4 minus 1, so y equals negative 5. Now what I love about all of these problems on this worksheet is you should know when you're done if all of your answers are correct or not, because you can check. So what I'm going to do is just do a quick check, plug these values into both equations. So if I plug it into the first equation, 3 times negative 4 is negative 12. Negative 4 times negative 5 is positive 20. Right? My pen's not working that great there. So negative 12 and 20 does make 8, which is what it equals. So that tells me that one's right. Check the other one though. It might work for one or not the other. This one here, does negative 5 equal negative 4 minus 1? Well, negative 5, does that equal, well, negative 4 minus 1 is negative 5. That one checks out. So I know my number 1 is exactly correct. All right, moving on to number 2. Here, we have both the x's and y's on the same side. When I see that right away, unless I have like a variable with no number in front of it, I'm going to do the elimination method. What makes this one a little more challenging is that 2 doesn't go into 3 nicely in either case. So on this case, I'm going to have to multiply both equations by some value. So I just need to decide which one I want to get rid of. I usually get rid of x's. It's just what I tend to do when I have a choice. So I'm going to multiply the first equation by 3 because I know 2 and 3 both go into 6. So what would I have to multiply 2 by to make it 6? I'd have to multiply it by 3. So I have that first equation where I'm going to have 6x here. Now I need to multiply the bottom equation so that I get it to be the opposite of 6, which is negative 6. So 3 times what is negative 6? Negative 2. And again, the reason why you're doing that is so that when you add those equations together, it will eliminate the x's. So I'm going to distribute. So I get 6x plus 9y equals 3 times 0 is 0. And I have 2 times 3, negative 2 times 3 is negative 6x. Negative 4y equals 20. Now, when you add these two equations together, the x's cross out. If I take a look here, 9 9y plus 4y is 5y. equals 0 plus 20 is 20. Divide both sides by 5, and y equals 4. Now, I have y, still need to find x. I'm going to plug it into the first equation here. So I have 2x plus 3 times 4 equals 0. So really I have 2x plus 12 equals 0. So if I subtract the 12, 2x equals negative 12. Divide by 2, x equals negative 6. I am going to do a quick check here. 2 times 4 is 8. 3, I'm sorry, it helps if I pick the right variable. Do a quick check again. 2 times negative 6 is negative 12. 3 times 4 is positive 12. They add up to 0. Check the bottom one. 3 times negative 6 is negative 18. 2 times 4 is 8. Add those together and it does equal negative 10. I know my answers are correct. All right, moving right along. Number 3, I am going to pick up the pace on here just a little bit. If I look at these two particular equations, notice how my x's and y's are on the same side. They line up nicely. So I'm going to do the elimination method. This one's nice because I know 5 goes into 10 2 times. So if I just multiply this equation by 2, I'll have 10x minus 16y equals 16. Now what's nice is I can add these two equations together because I have 10 and negative 10. So I'm going to go ahead and do that. So the y, or the x's cross out, sorry. Thought I changed colors there. So the x's are going to cross out. So if I look here, 4y and negative 16y add up to negative 12y. And then negative 7 and 16 end up being 9. So now, divide both sides by negative 12, and y ends up being negative 0.75. Now I know this one gives you a decimal answer. That actually can happen, but we'll double check just to make sure our answer is correct at the end. So I'm going to take that value, plug it into the first equation. So I get 5x minus 8 times negative 0.75 equals 8. Now I have 5x, a negative 8 times a negative 0.75 is a positive 6. So now I'm going to do minus 6 from both sides. So I have 5x, 6's cross out, equals 2. Divide both sides by 5. 2/5 is 0.4. And I have my answer. So one of the things I'm going to do with this one is, since I got some different answers, I'm going to check just to make sure my answers work. So when I plug it in the first one, 5 times 0.4 is 2. Negative 8 times negative 0.75 was 6. Hang on here. Because the two negatives, negative 8 times, it would make it a positive 6, sorry. 2 plus 6 does make 8. That works. On the next one, 0.4 times negative 10 is negative 4. 4 times negative 0.75 makes it a minus 3. Negative 4 minus 3 is negative 7. They do check out. My answers are correct. All right, moving right along to number 4. This one again, substitution. I see a y by itself. So I'm going to replace the y here with 3x plus 1. So I have 6x minus 2 times the quantity of 3x plus 1 equals 10. I'm going to distribute, so you have 6x minus 6x minus 2 equals 10. This one's a unique one because 6x minus 6x cross out, and I'm just left with this statement, negative 2 equals 10. Uh-oh, can that ever happen? Can negative 2 ever equal 10? And the answer is no. So when this happens, as we saw, we can get what we call no solution. Basically what it's saying is that these are parallel lines. All right, let's take a look at number 5. With number 5 and even number 6, we have some decimals, right? I know sometimes that will throw students off. So what I tell students to do is just think of the decimals not being there, at least in this first one, because they're all in tenths and this is a whole number. Or if you want to get rid of them, multiply everything by 10 at first. But what I like to think myself here is I can ask myself, do I want to get rid of the x's or do I want to get rid of the y's? Well, 2 doesn't go into 9 nicely, 4 doesn't go into 6 nicely. So one of the things I can do, multiply this bottom equation by 9, multiply this top equation by 2. The only problem right now is this is 1.8 and this is 1.8. I need to make one of them negative. So just for fun, I'm going to make the top one negative instead. So as I do this, I get negative 1.8x, and then I get a negative times a negative, negative 2 times a negative 0.4 as positive 0.8y equals negative 42. Then I do the next one. 9 times 0.2 is now the 1.8x. Then I have plus 5.4y equals 9 times negative 16, I believe is a negative 144. But just so that we can check, pull up my calculator, negative 16 times 9, yes, negative 144. All right, now let's combine like terms. Switch colors here, x's cross out, 0.8, 5.4 makes 6.2y equals, add these together, negative 186. Now, just need to divide by 6.2, divide by 6.2. So, I got my calculator here, negative 186 divided by 6.2, and I get negative 30. So y equals negative 30. Plug it back in and solve for x. So let's plug it back into the first equation here. 0.9x minus 0.4 times 30 equals 21. So 0.9x, 0.4 times 30 is 12. So minus 12 equals 21. Add 12 to both sides. So 0.9x equals 33. Divide both sides by 0.9. So x equals, let's find out here. So 33 divided by 0.9. 36.6 repeating. Curious here. Just want to make sure that I did everything right. I got a nice answer. Okay, well, I'll do a check here. 36.6 repeating. So I'm going to check on the first one. So again, 9 times this 36.6. So I can go 9 times my answer, since it's still in my calculator, minus 4 times negative 30, and I get, oh, it helps if I put the decimals, don't I? All right, let's try that again. 0.9 times 36.6 repeating. I'm just going to plug that in. That should be 33. So I have 33 minus, oh, I know what happened, I think. Let's see here. No, I didn't do that wrong. Okay, minus 33. Oh, no. Still trying to, oh, I see my mistake. Mr. Bartz, This, when I plug it back in, should have been a minus 30. Ah, see, even my mistakes. So that's going to make that plus 12. So I got to actually minus 12. So this ends up being 9. Oh, see, this is why it's always helpful to check. 9 divided by 0.9 is 10. Whew! Glad we found that mistake. See, that's why checking helps. See, even Mr. Bartz makes a mistake once in a while. So let's plug it back in now. 0.9 times 10 is 0.9. Negative 30 times negative 0.4. Right. Well, I don't know why I wrote 0.9. That should have been 9. Is 12. 9 plus 12 is 21. Check the last one. 10 times 0.2 is 2. Negative 30 times 0.6 is negative 18. 2 minus 18 is negative 16. Ooh, good catch, Mr. Bartz. That's why checking, see how I made just a little sign mistake, can make the biggest difference in the world. But see how checking helps you make sure you got the right answer. All right, next one. Wow, look at these decimals. Okay. So when I look at this one here, this is where I'd actually think about canceling the y's. Since one is positive and one is negative, I can ask myself, since it's 0.5 and 0.7, what number does 5 and 7 both go into? And that's 35. So I'm going to multiply this first equation by 7 and this second equation here by 5. Because when I do that, I will get a 3.5 and a minus 3.5y. So now I have to distribute the 7 first. So 4.2x plus 3.5y equals, and so let's go 6.4 times 7. And I get, what? How about if we clear the calculator for 6.4 times 7, and I get 44. What? Now it should be 44.8. There we go. That didn't make sense there for a second. 44.8. On the second one, I'm multiplying by 5. 5 times 1.4 is 7. That's 7x minus 3.5y. And then 5 times negative 44.8. So 5 times negative 44.8 equals negative 224. So now let's combine like terms. Add them up. 11.2x, y's cross out, equals, so now 44.8, I have the negative 224 in there, so I'm going to plus 44.8 to it. And I get negative 179.2. So let's divide both sides by 11.2. And I have x equals, so divide by 11.2, and I get negative 16. So x equals negative 16. Let's plug that back in and solve for y. So if I plug it in for x here, 0.6 times negative 16 plus 0.5y equals 6.4. So that's negative 9.6. So I'm going to add 9.6. When I do so, I have 0.5y equals 16. Divide, by 0.5. Y equals 32. So I'm going to just do a quick check just to make sure everything's right. I'm actually going to use my calculator here a little bit more to check it. So what I can do is go 0.6 times negative 16 plus 0.5 times 32. Sure enough, that gives me the 6.4. 1.4 times negative 16. And I'm going to subtract helps if I go 0.7. 0.7 times 32. So if I do that right, I should get negative 44.8. So I know my answers are correct. All right, last two problems here. Number 7. When I look at number 7, right away I'm going to continue to do this elimination part. So I'm going to multiply this first equation by -2, so my x's cancel out. You're actually going to see something probably right away when you do that. Because when you combine both of these equations, look at what happens. Cancels out, cancels out, cancels out. So you have nothing left on the left side. It equals nothing left on the right side. So that means they are the same line. And that means we have infinitely many solutions. We abbreviate that IMS. So number 7, that went really quick. Love them when they're that fast. All right, last problem. When I look at the last one here, I can see that -4 doesn't go into 6 nicely, but -5 does go into 15 3 times. So on this one, I just have to multiply the bottom equation by 3. So when I do that, I have 18x minus 15y equals -15. I'm going to copy the other equation right below it so that I can combine them nicely. So now, when I do, I have 14x, my y's cross out, equals -15 and 8 make -7. Divide by by a 14, and x equals -0.5. So x is -0.5. Take that value, plug it back in. If I plug it back into the first one, -4 times -0.5. Gotta make sure I copy that right. Don't make that mistake like I did earlier. 15y equals 8. So when I multiply those two together, I actually get 2 plus 15y equals 8. Subtract the 2. 15y equals 6. Divide by 15. So y ends up equaling, I believe, 0.4. So let me just do a quick check, make sure everything is a-okay. So -4 gets multiplied by -0.5. I'm adding 15 times 0.4. That does give me 8. Do the other one. 6 times -0.5 minus 5 times 0.4. Hit enter. Does it give me -5? It does. I know now all my answers are right on this worksheet. Good job. We are done with this video.